Hi, my name's Joe Stover. So I imagine I'm probably the only uninitiated devotee here. That's kind of scary for me. So please don't judge my wild harebrained ideas. But I first just a little bit of background on how I'm connected to Krishna consciousness. I feel like that's in order. I first started going to the Houston Temple in about 1996. So I've sort of been affiliated with ISKCON for a long time through various temples around the country. So I do have a long-term background in Krishna consciousness. I'm a mathematician, and my specialty is probability theory, stochastic processes, which I think that was actually Sataputa's specialty is probability theory as well. It's kind of an interesting connection. And also ecological theory. So I look at population models and think of a population as collection of individuals, and they reproduce and they die. And so the question is, well, what happens if you tweak that reproductive and death behavior? And I look at specifically, what happens if individuals behave differently. So some individuals are just naturally more likely to die early. Some individuals tend to live longer for whatever reason. And how does that affect the overall dynamics of the population? Does it allow the population to grow faster, or does the population go extinct faster? That's sort of what the ecological modeling connection is. Anyways, so I'm going to talk about space. So this is not my professional area of research. It's just something I'm very interested in, and that I do a lot of reading and really mostly podcast listening about. So without further ado, I've just made a couple of slides here. And so I'm going to chair this session. I'll introduce the other speakers, but mostly what my talk is going to be sort of a lightning fast overview of a bunch of different ideas. And it's just going to be asking a lot of questions. And I'll throw out a couple of mostly speculative ideas, mostly biased by my experience with mathematics. And hopefully it will either, provoke your thoughts or provoke you to share ideas that you already have. Okay, so let's do a little screen share here. So slideshow. Start my slideshow. Okay, so hopefully you can see that. Hopefully your screen is just black. So if your screen is pure blackness, then that's correct, because this is supposed to be a cartoon on the idea of space, because that's what you're looking at. So this is the title of the talk, and I'm just, like I said, I'm just going to give you just things to think about. And so, like, the question is, what is space? How should we conceptualize it? How should we think about it? How should we incorporate it into our mathematical or scientific models? How should we think about it within the context of a spiritual worldview? So we have this idea of physical space.
Do you want to swap the primary monitor, probably?
Let's see here. So you can't see words. Is that what's going on? Let me see here. Seeing the presenter view. Let me see here. How do I do that? Let's see here. How do I go to? Does anyone know how to click out of display settings? Swap present. There we go. How about that? Does that help?
There we go.
There we go. So now you can only see one slide. All right. I'll assume you can only see one slide.
Yeah.
So again, the question is, what is physical space? The space of the material universe. What does it mean for it to be physical? So I just have a list of concepts in here. There's this idea of an abstract space we can think of in our heads. I'll talk a little bit about mathematical spaces. One of the things we're really interested in here are scientific models of the material universe. And, usually these scientific models, usually they're based on a lot of, math equations. And within those math equations, there's, different types of spaces, which I'll sort of talk about. So I'm a mathematician. So I'm concerned with a lot of mathematical spaces, and this is really a non-technical talk, so just take everything I say with a grain of salt. So roughly speaking, we think of a space as a collection of things, but it's really important that there's some added structure. It's not just a bunch of beings floating around, not interacting. It's really important that there's some structure there. And so usually in math, we use the word collection or set to be quote unquote an unstructured space, just a collection of things with no relations between them. Okay, so the idea is that here's some examples. So like the whole numbers, there's counting numbers, 1, 2, 3, 4. So if you're going to think of those as a set, then they're not actually really numbers. There's no relations between them. There's no 1 is less than 2 as a set. 1 is less than 2, that's a structure. That's overlaid on top of the numbers. So to think of them as an unstructured, just think of it as just chaotic random dots just floating in nothingness. So the dots in this unstructured list, just dot, 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 dot. Those are meant to be sort of like what would become the numbers when you add some structure, but there's no structure there. So they're not even numbers yet. So when you turn them into numbers, it becomes structured. There's an ordering. 1 is less than 2 is less than 3, blah, blah, blah. 1 plus 1 equals 2, et cetera, et cetera. So that's sort of like a space where you have this collection of things, the numbers, and there's some structure overlaid on top of them. And so is that structure actually part of the numbers, or is it something that emerges from the numbers? Is it a property of our perception of the numbers, our interaction with the numbers? So that's going to be sort of like, an idea that's a theme here. So I'm going to introduce something that is interesting to me, the idea of measurement. In mathematics, it's measure theory. So the idea is that, well, whenever you experience something, whenever you have a conscious perception, you're, in some sense, you're measuring something. I think this is an idea in physics as well. So I'm thinking of measurement as analogous to conscious perception or conscious experience. And so I just want to illustrate this with a cartoon. Let's see here. There we go. So the letter M here is going to be sort of like a measurement function. It's kind of like, it's the jiva, the jiva experiences something, they're measuring something. And this box here represents, 2D space. Let's pretend jivas are living in 2-dimensional space. You generalize the idea to 3 dimensions or whatever dimension you want. That, so I feel like everyone here has sort of an intuitive idea of what a 2-dimensional space is, like a sheet of paper, the screen of your computer. And so in that space, there's a dot, and then there's a line. Okay, so we think of a line as 1-dimensional. Okay, just a linear extent of finite length, infinite length, whatever. And we think of a dot as 0-dimensional. Okay, now obviously when you're looking at the screen, that dot is not 0-dimensional. It's, you could measure its area on your screen. That line, it's not 1-dimensional either, really. It's got some extent. If I drew it, if I could actually draw it as really 1-dimensional and a dot as an actual infinitesimal dot, you wouldn't see them. Okay, that's actually the point here, that a 0-dimensional subspace and a 1-dimensional subspace, they're actually invisible. You can't see them. A 2D jiva cannot interact with a 0-dimension or a 1-dimension thing. And so this is like a real idea in mathematics, the idea of measure theory, that there's certain sets that have measure 0. And so that influences my thinking about this. I think that's an interesting idea to keep in the back of your mind here. And then so in scientific models, there's equations, differential equations, the Schrodinger equations, E equals mc squared, mass, kinetic energy, whatever. And all of these are built on, these mathematical spaces. You've probably heard the term Hilbert space, Banach space, vector space, different algebraic spaces, the space of whole numbers with ordering and addition and subtraction, multiplication, etc. So, is the space of those models, what does that mean? How does that actually line up with physical space? There's this idea that there's some real physical material space that we exist in or something. And then there's the scientific model of the interactions in that space. Does the space of that scientific model, does that really align with the physical space, the real space? It's an interesting question. Then of course, there's the other layer of the scientist thinking about the model, and there's a sort of an abstract or a conceptual space in the mind of a scientist. To what degree are they similar? And then, of course, there's a lot of really, far out there ideas in modern science, which, you could almost say that, there's no, it's not clear to me what is crazier, science or religion. They're both, pretty far out there. Higher dimensional space, lower dimensional space, the string theory is pretty wild. Here's another interesting thing is space discrete or continuous? This is an interesting question in philosophy and science, and different people have different biases here. There's another idea of space as emergent from some underlying non-spatial physical reality, which I find that idea really fascinating. I'm sort of stuck on that right now. And what do I mean by emergent? I don't know. There's an idea of strong emergence versus weak emergence. Weak emergence is like the thing that emerges is still, it's kind of like reductionism, where you have a collection of smaller things and then they combine to create something new. But that something new is really ultimately understandable in terms of the property of the smaller things. That's kind of like reductionism. But strong emergence is like where the thing emerges and you can't really understand that thing in context of its subcomponents. So I think, a Vedic worldview, this idea of strong emergence might be important. And then there was a talk about conformal scaling, which is not something I know much about, but that Roger Penrose's model, it's probably wrong. All these models are probably wrong, but it's a very interesting idea. And my thought is that, well, if conformal scaling is sort of a physically valid thing, then what does that mean for the nature of physical space, and the nature of size of that space in some sense? So I'm a non-expert on the Vedic ideas. I'm not going to throw out any sort of Sanskrit jargon terms here. I don't know them by heart. I can Google them. But I have read a little bit about it, and the idea is that space is the domain which allows the events of the material universe to unfold. And there's this idea of the universe, emanating from Vishnu's pores and then contracting into Vishnu's pores or something like that. But what questions I want to ask about that is, as a universe emerges from Vishnu pores, where is that physical space coming from? Is it being created from non-space? Like, is there a non-physical spatial reality being creating a physical spatial reality from that? Is it pinching off a bit of spiritual space and changing the nature of it? Is it taking something that's already existing? I think this is really kind of the what actually happens is there's this idea of space is still existing, the ether or whatever, but it's just unstructured. And then when it emerges and creates the universe, it's becoming structured. I think this is a theme that I'm trying to push here, that in some sense space is initially unstructured, and then when the universe is created, it becomes structured. There's this overlaying of structure on, and that's the difference between physical space and non-physical space. So my current bias is a sort of a pseudo-idealist point of view, where I kind of that if space emerges from a non-spatial reality, then in some sense it's really non-spatial, and I won't get into that. I'd love to talk more about that, but the idea is that spatial separation is essentially the conscious perception of spatial separation. And I'm not saying the jivas are creating the universe. What I'm saying is that Krishna's conscious experience is involved there too. But I don't want to go too much in depth there. I'll end with a sort of cartoon here. So here's the idea of unstructured formless space. So it's important that the black dots there are the space in a manner of speaking, but there's actually no space here. This is completely unstructured. This is not even empty space. This is pre-empty space. Okay. And when you overlay some structure there, okay, now we have a physical space, or at least a possible physical space. So the dots are, think of them as being like spatial grid points, and then the lines between them meaning that you can get from one point to the other. Or I like to think of the dots as like potential, conscious experiences for a jiva, and then the lines indicate, potential pathways, sequences of experiences a jiva can have, or relations between two different jivas having two different experiences, or something like that. And so here's a sort of a simple cartoon of expanding space within this sort of context, that you start off with unstructured space. The Big Bang is when structure first emerges, quote unquote Big Bang. And then expanding space would just mean that structure grows and becomes more complicated. You're grabbing, if we have this, I think Advaita Prabhu was mentioning this earlier, that you have this sort of infinite potential, then you can just continually grow the universe by adding on more and more structure, connecting more and more of these potential experiences or unstructured points. So this is just a cartoon idea. Don't take this too seriously. Anyways, that's all I had to say, and just hopefully there's going to be an interesting discussion, and I have lots of questions. I'm sure other people have questions.